Welcome to this video tutorial on FPOD data validation. This one is about boat sonars and related man-made sound sources. So even quite small motorboats generally have a depth finder. It produces pulses which can be at dolphin or porpoise frequencies. They're generally longer than the pulse or the click produced by a porpoise, which is considerably longer than the click produced by a dolphin. This sound beam goes down from the boat in a sort of cone, hits the seabed and is reflected back up. A tiny, tiny fraction is received by the boat, and the rest hits the sea surface and is reflected down from there, and then may go down to the bottom and back up to the surface and down again and hit a pod. So the pod's getting it generally after 2 reflections and maybe after 4. So let's have a look at some of this data. So what we're focusing on here is errors made by the Kernow-F classifier. So here are a couple of click trains that have been classified as porpoises. This display is showing the species, class, and the number of cycles. And this second panel here is the FP1 file, and in it, showing clicks per second, you can see this very flat line at about the same rate as the click rate in the click trains there. Earlier, you can see a lot of other frequencies, and we may get a better idea of how far this line extends if we filter the clicks in the raw data. So we'll just graph this view here, and it's showing us that the click trains that have been claimed to be porpoises wrongly are at about 126 kilohertz. And the wave number of the peak, that's the loudest cycle or wave within the click, is sort of spread over a range from 1 to about 12. So let's set a click filter here at 110 kilohertz. Refresh the view. And we can see that this straight line does actually continue earlier to some degree. It's a bit fuzzy there. And if we go earlier, I'll just move to the left there, you see that this sonar is definitely pre-existing for several minutes. And then it was not to be heard, although that little group there are just the right click rate. So that's probably the very first glimpse of the sonar. Okay, if we look more closely at these click trains, I'll just spread them out a bit here. You can see that the loudest cycle, so each line here represents the click, and that's the start, that's the end, and this dot is where the loudest cycle is. So sometimes it's quite late, cycle 12, and sometimes it's very early. We'll just find another example here. Yeah, you can see this again here. It can be really late. That's actually also quite a good feature. We've got that flat line, which is really the big one. That's the sort of diagnostic feature that's telling you, sorry, Kernow-F got it wrong. That is a sonar. And if we hit F4 there to see all the trains going on, you can see this flat line is picked out by the train detection. So we've got the flat line, we've got the wave number of the peak. Let's in this data set, the bad trains are marked. So we'll now exclude them. We'll get rid of ignore all filters. So now we're looking at things Kernow thought were porpoises, and in checking it out, we've agreed. So we'll do show from start, show next screen. So here's a group, no flat line showing there. Here's another group. And if we zoom in on these, we can see, looking at this position of the wave number of the peak, that it's much earlier. Um, yeah, it's coming out at 1 there, which is actually unusually early, but it's not spread all the way through. So that fits as well. Um, you might think that the narrowband high frequency index would be a good way to look at this data, but unfortunately it isn't, because both sonar clicks at porpoise frequencies do score high on that. They're narrowband, they're the right sort of length, the right kind of frequency. About the only thing they get wrong is this position of the peak. Okay, so that's the really key thing there, but there are other troublesome sources, and we'll look at one of these here. So this is data from the Yangtze, um, and it's kindly provided by Zhitao Wang of the Chinese Academy of Sciences. And here we're looking at click trains identified by the Kerner F classifier as other cetaceans or dolphins. Well, there sadly are no dolphins in the Yangtze following the extinction of the Baiji, the Yangtze River dolphin. And what we're looking at here is a set of click trains classified as dolphins that are around 400 to 500 clicks a second. It could just be sort of social communication, but when we look at the FP1, that is showing us a very different story, because this high click rate is going through 2 minutes here, and there's a lower click rate as well, and possibly a lower one than that. And if I zoom in, um, we can sort of see what's going on, and it is very extraordinary, and I have no idea what this source is. But these high click rates are in click bursts that are clearly click trains. So that they're being correctly analyzed, um, and they're occurring in this sort of regular fashion. So this is very unexpected, and it actually makes the point you do have to validate your files, and looking for sonars is one of the sort of basic tasks in that process. So that's actually pretty much the story of how you find boat sonars that have been mistakenly classified as cetaceans. So thank you for your attention.